discovery of an Earth-like planet one solar system away. This image shows how the surface of the rocky planet might look. It is the closest potentially habitable world ever detected outside our solar system.
Astronomers have hit the jackpot. This is a dream come true.
Nothing will be the same after this. The James Webb Telescope has spotted something shocking. Lights on Proxima B that eerily resembles city lights on Earth. This nearby planet, just 4 light-years away, might not only be Earth-like, but potentially inhabited. Could there really be others out there watching us from their own world? Tune in now to uncover the mystery of these alien lights on Proxima B and what they might be telling us. The James Webb Telescope's cosmic revelations. Proxima B is a planet that has gained a lot of interest. While it is similar to Earth, this is not the most important thing about it. Scientists have already found several Earth-like planets. Proxima B is special because it could be the closest planet outside our solar system. If the planet has an atmosphere, the greenhouse effect could make it warm enough for liquid water, placing it in the habitable zone. As the debate continues about the potential for life on Proxima B, one startling discovery threatens to change everything we thought we knew about this alien world. The James Webb Space Telescope is now looking at Proxima Centauri, which is only 4 light-years away. The telescope is providing clues about Proxima B. Some wonder if there could be artificial lights on the planet, possibly indicating the presence of life. These discoveries have caused a stir in the scientific community. The telescope is challenging what we thought we knew about the universe and the possibility of life. For a long time, humans have looked up at the stars, wondering if we are alone. The James Webb Space Telescope is now helping us find answers to these ancient questions. Proxima B orbits its star very closely, which exposes it to intense solar radiation. Normally, this would strip away any atmosphere. However, if Proxima B can keep its atmosphere, it may still be able to support life under the right conditions. The exploration does not stop with Proxima B. The James Webb Space Telescope is also examining other distant planets, using advanced methods like spectroscopy to study their atmospheres for signs of life. Each discovery adds more knowledge to our understanding of the universe. But finding life is not the only goal. Scientists are looking for specific markers, such as chlorofluorocarbons, which on Earth are linked to human-made activities. Detecting these could point to the existence of technologically advanced civilizations. The ongoing exploration with the James Webb Space Telescope is expanding the limits of science and technology. Every observation brings us closer to answering the big question: are we alone in the universe? Researchers face big challenges when trying to understand the signals that could reveal the secrets of a distant planet. As we begin this space adventure, JWST's advanced spectrometers act like a beacon of hope. It's designed to pick up faint signs like the dim glow of city lights or small clues of an atmosphere. In this way, the telescope becomes our eyes, watching over the edge of the unknown. It carefully filters through starlight, and JST's findings are key to figuring out what the atmosphere of Proxima B is made of. These findings give us clues about whether the planet might support life. The excitement builds as these discoveries could help us better understand how livable this alien world might be. The James Webb Space Telescope, peering through cosmic dust, catches glimpses of distant planets. This mission to learn more about the universe and our place in it is reaching new levels. The hope for future telescopes, which will be far better than what we have now, drives us to keep searching. We want to uncover the mysteries that hide our cosmic neighbors. New technology like the extremely large telescope, which should start working in the mid-2020s, could help us study atmospheres in great detail. This might even help us spot signs of life across space. The ability to detect ozone or other key signs in the atmospheres of distant planets could give us strong evidence of whether they can support life, or even prove life is already there. But this isn't just about technology. Our search for life beyond Earth is fueled by curiosity and deep questions about existence. If we do find life, it would change everything. It would force us to rethink our place in the universe. Are we truly alone, or are we part of a much bigger cosmic community? Let's see how our space tools today could lead us to tomorrow's discoveries. exposing the fabric of the cosmos. This journey highlights how amazing our current space tools are, but it also shows how much more we could achieve in the future. As we keep exploring, each discovery changes how we see the universe, shining light into the dark corners of space and growing our knowledge bit by bit. But the most exciting part? We may still be on the edge of something even bigger. Even with all the challenges, the idea of wormholes continues to spark our curiosity and leads to deep exploration. It pushes us to rethink the basics of how the universe works and what our place is in it. Could wormholes be the key to traveling between stars or even galaxies? Could they help us achieve things that seem impossible today? Superstring theory is one of the most complicated and fascinating theories out there, studied by famous physicists, including Michio Kaku. This groundbreaking theory tries to connect our understanding of the entire universe. It aims to combine Einstein's theory of gravity, which explains how large things work, with quantum theory, which describes the tiniest particles. This idea of uniting everything into one theory has been a major goal in physics, hoping to explain all the basic forces and parts of the universe in one framework. At the heart of superstring theory is a simple but powerful idea. What if the basic particles we know, like electrons and photons, aren't tiny dots, but instead are little vibrating strings? The way each string vibrates determines what kind of particle it is, kind of like how different vibrations on a guitar string produce different musical notes. The superstring theory also suggests something even more mind-boggling. Our universe may have more than just the 4 dimensions we experience, 3 for space and 1 for time. It proposes that there are actually 10 dimensions. These extra dimensions are thought to be so small and tightly packed that we can't see them. But they might explain a lot of mysteries in physics. For example, they could explain why gravity seems so much weaker than the other forces. In superstring theory, gravity might be weaker because it spreads across all 10 dimensions, while other forces are limited to the 4 dimensions we can sense. When we think about where the universe came from, newer theories have introduced ideas that sound like they come straight from science fiction. What if our universe was born from the collision of 2 other universes? Imagine 2 giant cosmic bodies existing in a multiverse, crashing together in a massive event, creating our universe with all its galaxies, stars, and planets. Another idea is that our universe might have come from another universe, like a cosmic Russian nesting doll, where universes keep creating new ones. One of the most surprising ideas is that our whole universe could be inside a black hole. This theory suggests that the center of a black hole, instead of being a point of endless density, could actually be the start of a new universe. If that's true, each black hole in our universe could be a doorway to another universe. These theories don't just challenge what we know about space, they also show us the limits of how we see the world. While we move through life in 4 dimensions, superstring theory suggests there could be even more dimensions we can't detect, giving us a glimpse of a much more complex, multi-dimensional reality. As scientists keep exploring and coming up with new ideas, studying things like black holes could reveal new truths about the universe. This journey connects the vast cosmos with the tiny world of quantum physics, testing the boundaries of what we believe is possible. And who knows what we might discover next? Next, we explore the powerful changes stars undergo during their lifetimes, exploring the supernova. Explosion. Energy is usually released when fusion happens inside a star. This energy moves to the star's surface and sends out tiny light particles, called photons, into space. As stars grow older, they use up their main fuel, hydrogen, and start fusing helium and carbon together. This creates new carbon elements. Once the helium is gone, the star begins to fuse neon and carbon, making iron. But unlike before, this process takes in energy rather than releasing it. This is because, at this stage, nothing in the star is strong enough to fight against its powerful gravity. When the star starts making iron, it begins to collapse, eventually leading to a massive explosion called a supernova. This explosion is one of the most powerful events in the universe, outshining billions of suns. Throughout their lives, stars change color, starting with a bright blue when they are hottest and turning a cooler red as they age. These color shifts show where the star is in its life cycle. But that's not even the most interesting part. As stars like this evolve, they go through fascinating changes. Looking back at history, people have noticed these color changes in stars. For example, around 168 AD, a Greek scientist named Ptolemy described a star called Betelgeuse as having a red color. Centuries earlier, Chinese astronomers said it looked yellow. These reports suggest that Betelgeuse might have once been a yellow supergiant. Big stars like Betelgeuse burn through their fuel quickly, which means they grow old faster. Even though Betelgeuse is only about 10 million years old, it's already nearing the end of its life. In comparison, our Sun, which is about 5 billion years old, is still in its middle age. Betelgeuse is expected to become a supernova soon because it's in an advanced stage of its life. It goes through cycles where it dims and brightens, with each cycle happening about every 5 years and lasting 100 days. During these times, the star's outer layer expands and contracts, changing its size and temperature. These changes help astronomers learn more about how red stars lose mass before exploding into a supernova. Recent studies have shown some unusual behaviors in Betelgeuse. For instance, it dimmed suddenly, outside of its usual cycle. This was surprising since it wasn't supposed to explode for another 100,000 years. Scientists also noticed that Betelgeuse was moving faster than normal, creating a bow shock as it traveled through space. At the start of 2020, Betelgeuse's brightness dropped dramatically. Then it leveled out and started to brighten again. But the dimming stopped so quickly that there was no sign of any big changes happening inside the star. This suggested that the dimming wasn't caused by a core collapse. Instead, it might have been due to star spots or a cloud of dust around the star, challenging earlier beliefs about how much dust impacts a star's brightness. Betelgeuse ejected a massive amount of material from its surface, sending it millions of kilometers into space. This material cooled and formed a dust cloud, which might have caused the dimming we saw from Earth. This ejection is helping scientists understand new star behaviors in real time, thanks to advanced telescopes like Hubble. Though we don't know exactly when Betelgeuse will explode into a supernova, it won't directly affect Earth because it's far away. However, when it does happen, it will create a stunning show in the night sky. Until then, astronomers are keeping a close eye on Betelgeuse, learning more about the lives of massive stars. When a solar flare erupts from the sun, it doesn't just disappear into space. Instead, this massive burst of energy can travel all the way to Earth, affecting our technology, atmosphere, and even our daily lives. These powerful bursts come from deep inside the sun, where magnetic fields are constantly moving and shifting. When these magnetic forces realign, they release a huge amount of energy, creating what we call solar flares. Now we'll focus on our own star, the Sun, and its effects on Earth's delicate dance with destiny. But the effects of these solar explosions aren't limited to the Sun. They send out streams of energetic particles that travel through space and reach Earth. This shows how powerful the Sun is and how much it can influence our planet. It's like a reminder of how delicate the balance is that keeps life on Earth going, with the Sun constantly watching over us. In the far future, our Sun will enter what scientists call the red giant phase. This is a big change in its life cycle, and it will bring major consequences for Earth. During this phase, the Sun will grow much larger as it runs out of fuel, eventually becoming so big that it will swallow the inner planets, including Earth. When this happens, Earth's oceans will boil away, and our planet will turn into a dry, lifeless place. But this isn't the worst part. As the Sun expands, Earth's atmosphere will be stripped away, exposing the surface to harmful solar radiation and leaving it as a barren desert. This future stage in the Sun's life is a reminder that nothing in space lasts forever, and that our planet's fate is tied to the Sun's evolution. Back in the 19th century, people experienced a powerful space weather event that had a major impact on the technology of the time. It's known as the Carrington event, which happened in 1859. This event was named after Richard Carrington, the British astronomer who first noticed the large solar flare that caused it. On what seemed like an ordinary day, Carrington observed the Sun, only to discover that a massive geomagnetic storm hit Earth about 18 hours later, causing huge magnetic disturbances. The effects were dramatic, especially for telegraph systems, which were the most advanced communication technology at the time. Telegraph operators saw sparks flying, machines running without power, and even papers catching fire. This event showed just how vulnerable we are to solar activity and how much chaos it can cause to our technology. Today, as technology is at the heart of everything we do, the danger of solar flares is even more serious. These natural eruptions of energy from the sun can threaten our power grids, communication systems, and satellites, leading to widespread blackouts or disruptions. The risks are real, which is why we need to be prepared and have protections in place to safeguard against the unpredictable behavior of the sun. Our fascination with the sun has pushed us to learn more about it for centuries. From early telescope observations to modern space missions, our understanding of the sun has grown deeper. One example of this is the Parker Solar Probe, a spacecraft sent to get closer to the sun than ever before to gather important information about its outer atmosphere, called the corona. In the grand dance of space, coronal mass ejections, CMEs, are also key players. These CMEs release large amounts of plasma and magnetic fields into space, and when they reach Earth, they can cause geomagnetic storms. These storms can mess with Earth's magnetic field and disrupt our technology. Knowing the difference between solar flares, which release radiation, and CMEs, which physically interact with Earth's magnetic field, is important for understanding and preparing for future events that could affect our tech-driven world. Solar activity can cause electric currents to flow through power lines, leading to major power outages and damaging important equipment like transformers. In today's world, where we depend so much on electricity and technology, the dangers from events like coronal mass ejections, CMEs, are more than just small issues. A powerful CME could disrupt communication systems, GPS, and even break down key infrastructure like water and transportation networks. Now let's look at how the sun's bursts of energy impact space and our world. The dance of plasma and power. The sun's magnetic field is constantly changing and very complex. It's not stable or predictable. This is because of the swirling movements of hot plasma beneath the sun's surface. These movements create a strong but ever-changing magnetic field. At the center of solar flares and CMEs is this magnetic field. A key process behind these energy bursts is called magnetic reconnection. Think of the sun's magnetic lines as threads of energy, always moving, twisting, and changing. Sometimes they snap and reconnect differently. When this happens, it releases a lot of energy all at once. This is what leads to solar flares and CMEs being thrown into space. But this isn't the worst part. The effects of solar events can reach far beyond the sun. Solar flares release a lot of radiation that can mess with Earth's atmosphere, affecting satellites and communication systems. CMEs, however, are even more dangerous. These huge clouds of plasma, when shot into space, can have a big impact on Earth if we are in their path. These impacts can range from beautiful auroras to intense geomagnetic storms that could knock out our electrical grids and technology. These events show how much solar activity can affect our daily lives and the technology we rely on. Just recently, the sun unleashed its strongest solar flare in almost 20 years. This event was a big moment for scientists studying the sun. The solar flare, classified as an X2.8 class flare, came from a very active sunspot known as AR 3102. The flare had immediate effects on Earth, causing a radio blackout across parts of South America. It was a reminder of how unpredictable the sun can be. The flare also caused beautiful auroras, which stretched much farther than usual, giving many people a chance to witness this natural wonder. But even this wasn't the worst part. In response to potential future solar storms, scientists have come up with a smart strategy to be prepared. This involves early detection, a better understanding of how solar events work, and ways to protect against them. Advanced solar observatories like the Daniel K. Inouye Solar Telescope play a big role in this. These observatories are key for both studying the sun and acting as early warning systems. They help scientists monitor coronal mass ejections in real time, allowing them to predict if and when these particles might hit Earth. By using data from these observatories, scientists are improving their ability to predict solar storms with more accuracy. This forward-thinking approach shows how committed we are to protecting our planet from the power of the sun. With better understanding and early warnings, we are getting ready for whatever the sun throws at us. This determination to understand and prepare for solar storms is as strong as the storms themselves. Thanks to advanced technology and scientific efforts, we are not just waiting to survive these solar events, we are preparing to thrive despite them. As we look to the sky, we do so not in fear, but with confidence, ready to face the future. What do you think? Are we over-preparing for solar events, or is this a necessary precaution? Let us know your thoughts in the comments, and don't forget to like and subscribe for more content like this.